Hi, I'm Robert Bolaños. Thank you for stopping by. And I wanted to take the opportunity to say thank you to the subscribers. I recently achieved a milestone. I got over 1,000 subscribers. Woohoo! Uh, and it's taken quite some time. But most of the subscribers are engineers or engineering students, which I'm quite pleased. And the videos that I'm producing are intended for the engineering community. An update in December made a video. My son had graduated from the University of Texas in San Antonio. He's looking for a job. In the meantime, that he's looking for a job, he's actually working with me, unpaid, at my place of employment at Southwest Research Institute. So he is gaining valuable experience. He's doing the rating on some of the designs, or actually on the power supply that I've designed, and he's doing quite well. So I'm preparing him that when he does have a job that he'll go after, he'll be very well prepared. And if not, I'm also hoping that they'll have a position within the institute within Southwest Research where he can gain employment. Anyway, that's an update on my son Robert. Very pleased with it. Been getting emails from time to time. This question regarding my background, where I went to school. I guess people are interested what I do or my educational background. So I decided to make a short, or actually make this video in case it inspires or helps other people become or maybe pursue the same career field or interest that I did. First of all, I live in San Antonio, Texas. I've lived here basically 50 years. I'm 54, and I was actually born in Mexico. I was born in Laredo, Mexico, and my parents immigrated when I was 3 or 4 years old. So basically, don't have too many memories of living in Mexico, and most of the memories that I have is here in San Antonio, Texas. Second, being from a family of immigrants, we were extremely poor. My dad was a carpenter, and my mother cleaned houses, and was also a cook. So I come from a very, very humble beginning. And a little bit more background: I have a brother, younger brother, and two sisters. They were born here in the United States. Okay. So that's, I guess, the background. And like I said, I was born in Mexico, and I've been living here ever since. Now, my first interest in electronics was sparked when I was probably 12 or 13 years old. The way I got started or interested in electronics was that I luckily had three uncles that were TV repairmen. I had my uncle Guillermo, my uncle Roman, and my uncle Marcelino. They were all electronic technicians and TV repairmen. But the first one that actually was my tío Guillermo. Tío means uncle. Okay. And what he did is, I believe I was either 12 or 13 years old. He took the high voltage cup of a television, and mind you, the cup or the wire that carries the high voltage has about 25,000 volts. So he disconnected it while it was off, and then he turned the television off, and he connected it close to the chassis, and he drew an arc that was about an inch long. So basically, what I saw was lightning, and to me that was so fascinating that it sparked an interest, and that he was, grabbing this piece of wire, he was shorting it to the chassis, he was drawing a big arc. So that literally sparked my interest in electronics. Okay, so and at the time that I began electronics, uh, televisions were mostly made out of vacuum tubes, or at least televisions that he was working on used vacuum tubes. There were transistors were just becoming to come out, or they were, I guess, beginning to propagate through the televisions. This is probably in the early 60s, 70s, late 60s, early 70s when this was happening. So that is what sparked. And then I started helping another uncle of mine here in San Antonio. Um, I would go work with him on Saturdays fixing televisions. When I say fixing televisions, at the time, fixing was the way you fix television was you change vacuum tubes. So you had a little, little meter where you would plug in your vacuum tubes, and you set the switches, and you would have a little meter that would say good or bad, and then you would also check for shorts. So it wasn't real electronics, but you had the capabilities that if you knew what tubes did what function, you could kind of have a make a good guess, educated guess what tubes to replace. And then if you had a little meter, you could actually measure the emissions of the tube. Okay, so that's how I started, and like I had mentioned, since I was 14 years old, my parents were extremely poor. I could not afford a soldering iron. Okay, and and I did have a couple of junk televisions, and I wanted scrap parts. In other words, I wanted to get parts like resistors, capacitors, and so forth. And some of these parts were connected on printed circuit boards. And since I didn't have a soldering iron, what I did, I would get a coat hanger. Okay, remember a coat hanger where you put your clothes. So I would straighten out the coat hanger and basically create, get the wire or the coat hanger, and then I would go to the kitchen. We had a gas stove. I would turn the gas stove on, and then I put the wire over the fire or the stove, and it would heat the wire red hot. And of course, I had to hold it far away, and it would get hot, but it would get hot enough for then it would be my heat source. So then I would get my printed circuit board, and then I would melt the solder, and I would do parts out. So being a kid, 14 years old, not having a soldering iron, that's how I desoldered parts, and I managed to salvage parts that I would be used on other circuits. So after that, I went to work for a TV shop at the age of 14 in the summers, and that's where I really got a lot of experience. Went to work for a TV shop called Cervantes TV in the summers. And I was 14 years old. And originally, I wasn't supposed to get paid. I was just supposed to kind of like hang around. But then when the guy noticed that I fixed one TV, and then another, and then another, and he noticed that I was actually fixing stuff, not just replacing tubes. I was, replacing open resistors, faulty capacitors, and so forth. So he started paying me $25 for each television that I repaired. So I was averaging anywhere from $100 to $140. And in the 1970s, that was a lot of money, and that was pretty good money for me for a 14-year-old. That was like really good. So I continued that until I graduated in 1979. And I went to work for. I got lucky enough to go work for RCA factory service at the age of 18. And I worked for RCA factory service. I would actually drive a van to make service calls. And I would go out with about 14 calls a day, meaning that I had to visit 14 houses. And out of that, they would expect you to fix at least 8 of them. So we had kind of quotas that we had to keep. Anyway, I worked there at RCA. I worked in the field for about 3 years, and then I was promoted to work inside. In other words, I became a bench technician. So, in other words, the televisions that the field guys could not fix in the field, they would bring it into the shop, and the benchman's responsibility is to fix those. So you really have to be real good to be able to fix those, because those are the hard ones. Now, the ones that you have problems fixing, we call them dogs. And those are the ones that everybody hates work, because those are the ones that take a long time to fix. But anyway, that's what I specialize. I specialize in working on what was called the dogs. I worked for RCA for approximately 13 years, and I became the lead technician there. But then, toward the end of my career, I noticed that fixing television was becoming less and less demanding, or not less and less in demand. In other words, televisions were becoming cheaper. They weren't increasing in price. So it was cheaper, or it was more cost effective to buy a new television than to have a fixed. So the handwriting was on the wall that eventually my career as a TV repairman would come to an end. So what I did is, at the age of 25, 26, I went back to school. And mind you, I didn't have a degree. I didn't have an associate's degree. I didn't have any degree. All I had was on-the-job training and stuff that I had learned on my own. And of course, whatever my uncles taught me. So I didn't have any really, really formal education when I went back to school. And I went back to college at the age of 25, 26. So, and I had to go because at the time when I was, I went part-time. I was going to school part-time, and then I kept working. And then I believe at the age of 32, RCA shut down for good. I had been laid off a couple of times, but they shut down when I was 32, 33. And they had a plant closing benefit that if they shut down the plant, that RCA would pay 3 years of your education. So I took advantage of that. And since I was laid off, I went to school full time. And by that time, I had already been going to school since 26, the age of 26. I had already built up some credits. So by the age of 35, I finally graduated with a engineering degree. So basically, it took me from 26 to 35, that's 9 years, uh, to get my electrical engineering degree. When I graduated with my engineering degree, I went to work for Sony Semiconductors here in San Antonio, Texas. Now, when I got hired at Sony, I, I had quite a bit of electronic experience. Uh, but in the position that I got hired at Sony, it required a little bit different skill set. It was more of a industrial electronics, which is a little bit different from electronic, uh, pure electronics. It's a little bit different, and I wasn't as familiar with the industrial electronics, so it took some adjustment to get used to it. But nevertheless, I worked there at Sony for 8 years. I was what is referred to a etch engineer. I worked on, like I said, industrial electronics. Also worked on hydraulics and pneumatics, and it was a pretty good job. I enjoyed it. There was a lot of really good people. But again, for some reason, Sony wasn't making any money, so they decided to shut down the plant. So that was the second company that shut down and left, closed its doors. So again, I was unemployed and had to look for another job. So I went to go work at Motorola. I worked at Motorola for about 1 year, and that was Motorola in Seguin, Texas. Worked 1 year. I had to commute about an hour both ways, and then in 2003, I was lucky enough to land a job at Southwest Research. Okay, and I landed a position where I got to design stuff. Instead, prior, I had always been fixing stuff. Now I got a chance to design stuff, and that was a great opportunity for me because I had always wanted to design stuff. So basically, it was my dream job. Okay. Now prior to that, like I said, while I was working at Sony, I started my advanced degree, and I enrolled in what is called the engineering outreach at the University of Idaho, and that was probably the best move that I ever did. Uh, Basically, it's kind of like a online uh, electrical engineering course. It's at the University of Idaho, but it's called Engineering Outreach. And basically, you take the same classes that they all on-campus students at Idaho take. And I started my master's degree, and I was specializing at the time since I was working at Sony. I wanted to design chips, so so my master's involved microelectronics, VLSI design. So I started my master's doing that, and with the intent of designing chips for Sony. Well, I didn't finish my degree while I was at Sony, but I kept uh, taking the classes, and eventually I graduated with my degree in 2007. Uh, Defended my thesis up in Idaho, and that, like I said, that was the best decision that I ever made because the University of Idaho has a very strong analog curriculum, very rigorous, and most of the the skills that I picked up in design were picked up at the University of Idaho. In fact, some of you may have seen my videos on the Zebra Smith, and on some of the videos, I dedicate the videos to my analog professor, Dr. Kenneth Noren, who passed away about 2 years ago. So that's why I dedicated, because he taught me a lot, and I'm really indebted to him. But basically, that's what I've been doing. Now I design switching power supplies for space. Been doing that already for about 11 years. It's a great job. It's a very unique job. There are not many engineers that get to design power supplies for space. The power supplies that I designed eventually go into NASA projects. The first project that I worked or got a chance to assist, okay, when I first joined the Southwest Research, was a project called New Horizons. Now, next month, in July, or later part of this month, the New Horizon you'll be hearing in the news. New Horizon is the spacecraft that was launched approximately 10 years ago, okay, and it was launched to the planet Pluto, okay. This is before Pluto got downgraded to a dwarf planet. But this New Horizons spacecraft main mission is to study Pluto. And there's an instrument in there called SWAP, S-W-A-P, and it stands for Solar Winds Around Pluto. And it's an instrument, and it's powered by a high voltage power supply. And I'm glad to say that I assisted in the testing. Did not design it, but I assisted in the testing. I actually got to hold the power supply. So in a sense, right now, that is the furthest thing in space that one could touch, build, and then send out to space. It's millions and millions of miles away from us. It should be in orbit around Pluto. And just thinking about that, thinking that something that I touch is in space, and especially that far away, it kind of boggles my mind, at least, that I'm able to do things like that. Another thing that you can think about is that human history, or recorded human history, may be maybe anywhere from 5,000 to 10,000 years. Okay. So in reality, in terms of the time the Earth has existed, let's say Earth has existed for 5 billion years. Well, if you take that portion, 5 to 10,000 years that humans have existed on Earth, it's a very, very small portion. Very, very, very small. Now, if you consider dinosaurs, they said the dinosaurs ruled the Earth, or existed on Earth, for hundreds of millions of years. So when you look at the length that a dinosaur has been existed or ruled the world, and then the little time that we've existed, we've only existed for a very, very short time. Okay. So what does that have to do with power supplies? Okay. Well, think of this. The pyramids are a couple of thousand years old. Okay. And with time, they've eroded. Okay. Anything that we build gets eroded. Okay. Just about everything. Okay. So if you think in terms of a million years in the future, if we don't kill ourselves, we might still exist. But if we do, or don't exist, the pyramids eventually will erode. there'll be nothing but sand. Our existence will probably also just erode, I guess. Okay. However, when we build a power supply or a spacecraft, that spacecraft is in space. So there's nothing in space that can erode it. Now, it doesn't mean that it's going to work forever. It doesn't, because the radiation will damage the component. But at least, we have a spacecraft or a box. We have something tangible that, that someone has built and designed. Now, from that perspective, I'm building stuff that gets sent up in space that will literally outlast the pyramids. Okay, so I get to build stuff that would basically, for all intents and purposes, will last for an eternity. Okay, so thinking about that also gives me another perspective that wow, it's a very unique job, and it's something to think about. So anyway, that's what I just wanted to give out. I hope I didn't bore you guys out, but that's a little bit of history, and hope you maybe learned a little bit from my perspective, from my background. Anyway, I want to give a shout out to my friend Anand in Mumbai. He's one of my students, very talented. I want to say hi to him. And I also want to say Melvin, Cambodia. Give a shout out to Melvin. He's another excellent student. Always he's emailing me with good questions. So Melvin, keep on sending the questions, and I'll keep remember, provided that I have time, I'll respond to your questions. Anyway, thank you for watching, and hope you have a good night.